Hello, this is Saxon Math, Course 1, Lesson 10. It's called Sequences and Scales. Let's just get right into it. A sequence is an ordered list of numbers that follows a certain pattern. So find that pattern and continue it. An addition sequence would be the same number is added each time to each term. So like 2 plus 2 plus 2 results in 2, 4, 6, 8, 10. That's an addition sequence. A multiplication sequence, each term is multiplied by the same number, like 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 would be 64. And it goes on to infinity just like that, multiplying it by 2. This one you can see would go on to infinity, adding it by 2. So that's an addition sequence. This is a multiplication sequence. We'd just multiply by 2 again. You get 128. If you were to multiply by 2 again, you'd get 256. And you just keep going. Even numbers end with 0, 2, 4, 6, or 8. Odd numbers end with 1, 3, 5, 7, or 9. Also, part of this lesson, a scale is a display of numbers similar to a number line with an indicator to show the value of a certain measure. Find the value of the marks on the scale first, then you read the indicated number. So, for example, if you look at, let me go to the scale. Actually, we'll come to that again here soon. But first, you want to look at the value of the tick marks on your scale. So if you're looking at it, how much is each tick mark representing? Is it this is 0 and this is 5 and this is 10 and this is 15? Or is it 0, 2, 4, 6? Or is the value going to be 0 and 1, 2, 3, 4? What's the value of the tick marks going to be? Then you can read the indicated number. If it's at this level, it's worth 4. If it's at this one, it's worth 6 on this particular scale. On this one, it would be worth 15, even though they might be the fourth tick mark from the bottom. So you have to consider that when looking at scales. And let's look at this one piece at a time. So a sequence is an ordered list of numbers called terms that follows a certain rule. Here are two different sequences: 5, 10, 15, 20, 25. Here's another sequence: 5, 10, 20, 40, 80. The sequence in A is an addition sequence. So this is just another example of an addition sequence because the same number is added. What is that number? Well, you can tell that you would add 5 to 5 to get to 10, plus 5 more would get you to 15, plus 5 more would get you to 20, plus 5 more would get you to 25. On this one, it's a multiplication sequence because each term is multiplied by the same number. In this case, it'd be times 2 to get you to 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. So it's a multiplication sequence. So when we're asked to find an unknown number in a sequence, you have to inspect the numbers to discover the rule for the sequence. And then you can use that rule to find the other numbers in the sequence. So we would know what the next one, if we were looking for the next term in the sequence, if we're going to multiply by 2, would be 160. We also would know what the next one and this one would be. We'd add 5 to the last term in the sequence to get 30. And we could go on to infinity. You could just keep moving through that. Multiply times 2 if you're doing a multiplication sequence here. Sometimes it could be a different value, obviously. It doesn't always have to be 2. It could be a different value. It could be multiplying by 3. So let's say you had, I don't know, let's say we have 4, 12, 36. And then what's the next one? Well, in this case, this is times 3. This one would be times 3. This would also be times 3 to get to, in this case, it would be 90 plus 18 makes 108. That would be the next term in this sequence. If it's a multiplication pattern similar to this, but it's times 3 instead. Okay, so just keep that in mind. It doesn't always have to be the same sequence. Okay, let's look at this one. Describe the following sequence as an addition sequence or a multiplication sequence, and then state the rule of the sequence and find the next term. So if you have 1, 3, 9, 27, and then what's the following term in the sequence? So if I look at this, I could say, hey, it's plus 2. Well, I wouldn't be able to plus 2 to that 3 to get to 9, so that's not going to work. So I'm not going to do an addition sequence, but I can see that 1 times 3 gets me to 3. 3 times 3 gets me to 9. 9 times 3 will get me to 27. That means I need to take 27 times 3 to find out what the next term is, and I would get 81. So that means the solution has to be 81. So it's a multiplication sequence because each sequence can be multiplied by 3 to find the next term. Multiplying 27 by 3, we find the term that follows 27 in the sequence is 81. This is a special sequence, 0, 2, 4, 6, 8. It's called even numbers. Even numbers is another way of saying a sequence. We say even numbers when we count by twos. Notice that 0 is an even number. Any whole number with a ones digit of 0, 2, 4, 6, or 8 is an even number. Whole numbers that are not even numbers, the special sequence is called odd numbers. They're 1, 3, 5, 7, and 9. An even number of objects can be divided into two equal groups. An odd number of objects cannot be divided into two equal groups. So anytime you have an even number of objects, it can be divided into two equal groups. Odd numbers of objects cannot be divided into two equal groups. Here's an odd number. What's 3 divided by 2? Well, 3 divided by 2 would be 1 with the remainder of 1 or 1.5. So you see it doesn't work. If you did 4 divided by 2 though, you get 2. So you get odd number of objects cannot be divided into equal groups. All right, let's look at this one. So think of a whole number, double that number, and is that number answer even or odd? So let's look at a whole number. Let's say it's 12. Double it, that means times 2, that's 24. Let's think of another whole number. Let's say 8. 8 is a whole number. It's times 2, that's 16. Okay, let's try another whole number. 7 times 2. What's that equal? 14. All right, let's try another whole number. Let's do 5. 5 times 2, we're going to double it. 10. Okay, what about 3? 3 times 2. 6. What about 280 times 2? What's that? That's 400 plus 160. That makes 560. Okay? Is the answer even or odd? Even, 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 and even. That answers our question. The answer is even. Doubling any whole number, whether it's an odd number or even number, will result in an even answer. So anytime you double it. All right. Is often presented to us in the form of a scale. A scale is a display of numbers with an indicator to show the value of a certain measure. To read a scale, we first need to discover the value of the tick marks on the scale. Marks on a scale may show whole units or divisions of a unit, such as 1/4, as with the ruler from Lesson 7. We study the scale to find the value of the units before we try to read the indicated number. So to commonly use scales on thermometers, we have the Fahrenheit scale and the Celsius scale. Those are two commonly used scales. A cool room may be 68 degrees Fahrenheit or 20 degrees Celsius. The temperature at which water freezes under standard conditions is 32 degrees Fahrenheit, abbreviated 32 degrees Fahrenheit, just like this, and 0 degrees Celsius, which looks like this. The boiling temperature of water is 212 degrees Fahrenheit, which is 100 degrees Celsius, and the normal body temperature of a human being is 98.6 degrees Fahrenheit or 37 degrees Celsius. The thermometer on the right shows three temperatures that are helpful to know. You've got the boiling temperature of water at 212 degrees or 100 degrees Celsius. The normal body temperature was 98.6 or 37 degrees Celsius, or freezing temperature of water at 32 degrees Fahrenheit and 0 degrees Celsius. So here it is again. You can see this is the Kelvin scale, the Celsius scale, and the Fahrenheit scale. These are all similar. Water boils at 212 degrees Fahrenheit. It's 100 degrees Celsius. On the Kelvin scale, it's 373 Kelvin. These are all going to measure the same types of things, water boiling, body temperature, and freezing water, but they are just measured in different units. Freezing water, 32 degrees Fahrenheit, 0 degrees Celsius, 273 degrees Kelvin. Here's some more scales, thermometers that we're used to seeing, Fahrenheit, Celsius on either side. So what temperature is shown on this scale, on this thermometer? If you look at it, you can see that it's at, here's the 0 mark, 0 tick mark. Here's another tick mark, and then there's another tick mark. And here it goes up to 10. So if you just check it, if this was 2, this would be 4, this would be 6, this would be 8, and this one would be 10. So that means we're at the 4. We're at the 4 right here. This is 4. And that'd be 4 degrees Fahrenheit on that particular scale. All right, let's try the practice set here. For the sequence in problems A and B, determine whether the sequence is an addition sequence or a multiplication sequence, and then find the next three terms. So for letter A, if we're looking at this one, you can see that it has 18, 27, 36, and then 45. So in this case, you can see that it's an addition pattern. If you look at the numbers, they all have a difference of 9. If I take 27 minus 18, I get 9. So if I'm going to add 9 to this, I would end up with 54. If I add 9 to that, it would be 63, and 9 more would be 72. On letter B, it looks like it's a multiplication sequence. Go ahead and answer that one. So it goes 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 would be 16, 16 times 2 would be 32, and 32 times 2 would be 64. Letter C, think of a whole number and double that number, then add 1 to the answer. Is the final number going to be even or odd? Okay, and your answer for that should have been odd. If you remember, if you take any whole number, let's say 3 times 2, we're going to double it, you get 6, but then it goes a little further, then add 1. 6 plus 1 equals 7. That's an odd number. Odd. 7 is odd. Letter D, this thermometer indicates a comfortable room temperature. Find the temperature indicated on this thermometer to the nearest degree Fahrenheit and to the nearest degree Celsius. If you look at it, you can see the blue line is right here. And if I now look at the tick marks, I determine it as, if I'm looking at Fahrenheit, I got, let's say this 72, 74, 76, 78, 80. So this would be 72 degrees Fahrenheit. And if I'm looking at the Celsius scale, I can see it's 20. There's 1, 2, 3, 4, 5 in between 20 and 30. So that means each one of those has to be worth 2. This is worth 2. This would be 22, this would be 24, 26, 28, and then 30. So that means this would be 22 degrees Celsius. All right, and that should be all of the questions, I guess. So go ahead and do your written practice 1 through 30. You can start working on that and put it on your paper and then answer it in your Grow Formative when you're finished. Have a great time, and we'll see you next one.